1.5 billion gallons of drinking water a day. That's how much we use in Michigan. About 150 gallons for every one of us, every single day. We simply can't live without it. Most of the time, though, we don't think about our drinking water. We just turn on the tap and it's there, ready to nourish, to drench, to clean, and to quench. Good, clean, safe drinking water. Did you know there's never any new water? The water we have today is the same water our Earth has had for billions of years. Nature recycles water through evaporation, transpiration, condensation, and precipitation. When rain or snow falls to Earth, some seeps through the ground and collects in aquifers, creating what we call groundwater. The water that we see on the Earth we call surface water, most of which is salt water in the oceans. Only 1% is fresh water in our rivers, lakes, streams, ponds, and springs. The Great Lakes Basin, where we live, has 1/5 of all the fresh water in the world. But how does the water get from nature's sources to our faucets? Some families have private residential wells that pump groundwater right out of an aquifer directly into their homes. For most of us, though, the source water takes an important detour through a public water supply system where it is carefully treated and consistently monitored to make sure it's safe to drink. A number of public systems tap into sources of groundwater, drilling large municipal wells to take their supply from aquifers. Some groundwater needs only limited treatment, the removal of iron, for example, or adding a disinfectant to kill harmful bacteria, or fluoride for healthy teeth. But other sources of groundwater and all surface water need more sophisticated treatment at public water treatment plants. Large or small, water treatment plants do basically the same job. Pump water in from a carefully chosen source and send it through several physical and chemical processes to remove impurities, destroy harmful organisms, improve taste and odor, and to soften water. During a process called sedimentation, water moves slowly in a tank called a clarifier. Approved chemicals are added to help large particles coagulate or clump together, so they sink to the bottom to be removed. The cleaner water then continues to the next process, filtration, where filters capture still smaller substances as the water flows through. Another method is microfiltration, which uses filters with very small membranes that catch tiny particles. Every few days, the plant operators backwash the filters to remove the trapped materials. The cleaned filter is then ready to go back into service. Finally, disinfection helps prevent disease. The disinfection of drinking water, done for more than 100 years primarily with chlorine, was noted as one of the top 10 scientific advances of the 20th century. Chlorine and other modern disinfection technologies, such as ozone and ultraviolet light, have all but eliminated outbreaks of cholera, typhoid, and other waterborne disease. To protect the public health, both federal and state safe drinking water laws set strict standards for water quality and for the operation of public water systems. Every public water supply must have a licensed operator in charge, an experienced operator who has passed a written examination administered by the Michigan Department of Environmental Quality. And each water utility must prepare an annual consumer confidence report to fully inform its customers about the quality of their drinking water. To assure quality is maintained throughout the treatment process, specially trained and certified operators monitor the equipment, chemicals, and amount of water needed in the system. Only approved chemicals and materials are permitted to come into contact with the water. In certified laboratories throughout the state and at the Michigan Department of Environmental Quality, technicians test the quality of the water again and again to make sure the treatment process is doing its job. If any violation occurs, the public must be notified. Chemists and microbiologists use sophisticated electronic instruments to detect microorganisms, pesticides, harmful chemicals, and other substances. Measurements are made in parts per billion, parts per trillion, or even smaller. Imagine, 1 part per billion is as small as a single drop in a 10,000-gallon pool. Laws also regulate the design and construction of public water systems. Engineers face the challenges of planning facilities that will meet increasing demands, accommodate more advanced and efficient treatment methods, and enhance the security of our public water supplies. Design criteria also require backup systems to assure a reliable, safe water supply in the event of a problem. Supervisors and managers, operators and technicians, engineers and designers all make the highest use of their many years of education and training in order to deliver water of unquestionable quality. After all, the safety of our drinking water is in their hands. Distribution system operators, also trained and certified, work to maintain and repair hydrants, valves, and water mains. They take special care to keep our drinking water safe and keep it flowing through miles and miles of underground pipeline, the transportation system for our public water supply. The water tower is perhaps the most visible and familiar part of public water systems. Regularly inspected and maintained, water towers and ground storage reservoirs do 2 things. First, they keep plenty of water ready for our use, so it's there especially when we need it most. Second, they provide water pressure, either by gravity or by mechanical pumps. Pressure makes the difference between a gush and a trickle. All along the way, from its carefully assessed natural source, through the regulated treatment process, and down the complex distribution system, public drinking water is closely monitored, protected, and secured. When the water reaches the service lines in our homes, schools, and businesses, you can be sure that it meets strict standards, is of the highest possible quality, and safe to drink. Keeping rates reasonable is one more goal of public water supply systems. By routinely inspecting every part of the system, with ongoing investments in maintenance, repairs, and improvements, we can add years to the useful life of our public water facilities. Rate increases are necessary as demand for water grows, as infrastructure ages, as regulations increase, and as security concerns rise. But with all that goes into making our water safe, reliable, and secure, it's still one of the greatest values around. And best of all for our budgets, there's no need to spend dollars buying water at the store. For just pennies a day, safe public water is delivered, ready at the touch of a finger for instant on-site use or to fill up and go. Remember though, there's never any new water. Some of what we use seeps right back into the groundwater. Some goes down the drain as wastewater. Wastewater is treated too and then returned to the water cycle. As water falls through the air and runs over the land, it picks up substances put there by animals or by human activity, like viruses and bacteria, salts and chemicals, air emissions, as well as pesticides, herbicides, and fertilizers, substances that may reach our rivers, lakes, streams, and groundwater. Keep it out, not take it out. That's the aim of source water protection programs, storm sewer control and sewer separation projects, land use, zoning, and environmental regulations, and community recycling efforts. It's just plain common sense, and it's up to each of us individually to do our part to comply and participate, because after all, it's the only water we'll ever have. To find out more about what you can do, call the Michigan Department of Environmental Quality. The people, the plants, the process, the pipelines, the protection. Michigan public water systems, whether they serve large or small communities, all have the same goal: to deliver to you, when and where you need it, sparkling clean, safe drinking water.